A star fills the frame like a blown-out streetlight at midnight. Not a pretty star, a practical one. A white glare that refuses to behave. And then off to the side, barely there's a second point of light that shouldn't be there. An exoplanet, HR 8799b, not discovered by a wobble or a dimming, but by trying to look directly into the flood and still find the ember hiding next to it. This is the cosmic checkpoint, because before we chase signs of life, before we even allow the words biosignature or technosignature to hover near our tongues, we have to accept what direct imaging asks of us. It asks us to trust a picture that begins as a problem. The star is brighter than the planet by orders of magnitude, and the instrument does not see a clean scene. It sees a battlefield of leftover light patterns, ripples, fragments of the star's own brightness, broken by optics and detectors, into something that can masquerade as structure. That masquerade has a name we will return to again and again: instrument systematics. Here the story is already tense. Signal versus artifact. An exoplanet atmosphere versus the starlight that contaminates everything around it. In direct imaging, what reaches us from the planet is the planet's own light shaped by its atmosphere, its heat, its clouds. But the same data also carries the telescope's fingerprints, and those fingerprints can look eerily like physical features. High contrast imaging produces speckles, residual starlight patterns that cling to the image even after we do everything we can to remove them. They are not random noise. They can be stable. They can be persuasive. HR 8799b sits inside that persuasion. We're not watching a distant world float serenely in blackness. We're watching it struggle to be seen through the glare of its parent star, through a field of false structure that can form halos, arcs, ghosts, shapes that feel like discovery. And the title of this episode is A Warning Disguised as a Promise: Direct Imaging Halo of HR 8799b, Speckle Artifacts, a months-long analysis. The halo is the hook. The speckles are the thread. The months are the cost of credibility. And somewhere in that phrase is the moment the data refuse to fit. If you're used to exoplanets as tidy graphs, little dips in starlight during a transit, smooth curves in radial velocity, this looks different. This looks like hunting a whisper inside a hurricane. The planet's light is faint and close to the star in the image, where the contamination is worst. Direct imaging can in principle put a planet on the screen and open the door to spectroscopy, later reading an atmosphere by the way it colors the planet's light. But this door has a locked calibration. Without calibration that holds, without uncertainty that's honestly faced, the thing we call atmosphere becomes a projection. So we slow down. We take the supposed halo seriously, but not romantically. A halo, if it's real, could hint a scattering around the planet. Something extended. Something like high-altitude haze, or clouds shaping the light, or even circumplanetary dust. But the key word is if, because speckle artifacts can create halo-like structure near bright stars. And a false positive at this stage doesn't just mislead the eye, it misleads every later step. It biases the planet's brightness. It contaminates the spectrum. It poisons retrieval, the process of turning light into an atmospheric story. There's a temptation, especially when you hear halo, to leap ahead. To imagine a world wrapped in an atmosphere, to ask whether gases might carry signs of life, whether a technosignature could one day imprint itself on such faint light. Industrial molecules, odd reflectance, something unnatural. But here we are nowhere near that. Not because it's unthinkable, because it's unearned. The techniques refined in cases like HR 8799b are part of the long road toward evaluating biosignatures and technosignatures in exoplanet atmospheres. But this episode is about the gatekeeping step proving that the light we think belongs to the planet truly does. And that's the quiet, ominous part. The universe isn't simply hiding answers. It's offering us illusions that look like answers. The star's leftover light can dress up as planetary structure. The instrument can impersonate an atmosphere. The data can refuse to fit a clean narrative, not because there's nothing there, but because there are too many ways to be fooled. Our first concrete test is not philosophical. It's practical. We name the confounder instrument systematics, wavefront errors, and subtle instabilities that form speckles. We admit that these speckles can persist, that they can be mistaken for faint halos, and that the line between discovery and artifact is drawn by method, not mood. Uncertainty is not a footnote here. It's the plot. So we hold on that image, star-masked planet present, and the faint suggestion of mist around it. The halo that may be physics. The halo that may be a trick. The title's promise is already tightening. Direct imaging gave us a world, and then a halo appeared and it refused to fit cleanly. If we want to say anything about an exoplanet atmosphere, anything that could someday matter for signs of life, we have to earn it through process. And that process is where we go next. From wonder to procedure. From a haunting shape near HR 8799BE to the months-long analysis that tries to break it apart piece by piece until only the truth, whatever it is, remains. The first thing you learn in high-contrast direct imaging is that the raw frame is not a photograph. It's a confession written in glare. The star dominates. The detector is saturated with brilliance and structured leftovers. And somewhere inside that structured light, the exoplanet is present as a faint, stubborn pattern that only becomes real after you've tried to destroy it in every way that a false positive would survive. So the work begins with a kind of discipline that feels almost moral. You don't start by believing the halo around HR 8799B. You start by asking how easily you could manufacture it. The team doesn't take one image. They take many. They lean on time and geometry. The sky rotates. The instrument stays fixed. That difference matters. In direct imaging, one of the simplest sanity checks is motion. What moves with the sky versus what stays glued to the instrument. If a feature tracks the instrument's orientation, it smells like instrument systematics. If it behaves like it's attached to the exoplanet's position on the sky, it earns a little more attention. Not belief, attention. This is where the title thread tightens again. Direct imaging halo of HR 8799B. Speckle artifacts a months-long analysis. Months-long because the halo refused to fit neatly into the first reduction or the second. In this kind of data, a single processing choice can turn faint structure into a story. And the story can be wrong. They begin with calibration, quiet, meticulous, unglamorous, flat fielding to correct pixel-to-pixel response, bad pixel maps, detector behavior that changes subtly across the frame. If the detector has quirks, those quirks can masquerade as extended light. Instrument systematics isn't just one villain. It's a family of them. Then comes the star subtraction problem, the central ritual of direct imaging. You build a model of what the star looks like in the instrument, not the ideal star. The star as seen through optics that introduce diffraction and wavefront errors that spawn speckles. You subtract that model, and you pray you haven't subtracted the planet with it. Because that happens. It's one of the cruel jokes of the method. The same algorithm that helps you reveal an exoplanet can also self-subtract it, carving away real planet light and leaving behind shapes that look like halos, rings, or voids. Here is an evidence moment, the kind that keeps you honest. You run the reduction more than one way. You change the assumptions. You change the parameters. You ask whether the halo is stable or whether it blooms only under a particular set of choices. This is not aesthetics. This is a test against a confounder instrument's systematics and model assumptions working together to sculpt what you think you see. They lean on redundancy, independent pipelines when possible, different team members making different choices, and then a deeper test injection and recovery. You take the raw data and you add something artificial, an exoplanet-like signal, sometimes even a faint extended component, and you see whether your reduction method can recover what you put in without inventing what you didn't. If a method tends to create halos around point sources, it will do it to your injected planet too. If it erases faint extensions, it will erase your injected halo as well. This isn't a guarantee of truth. It's a stress test. And there's another kind of evidence moment, quieter, but devastating when it fails repeatability. You look across observing conditions, across nights if you have them, across small changes in the setup. A real astrophysical component should behave with some consistency. An artifact can be fickle, or worse, it can be consistently wrong in a way that mimics consistency. Speckles can be quasi-stable. That's why the title doesn't just say speckles, it says speckle artifacts. The artifact is the interpretation that speckles invite. At this stage, the halo is not yet a statement about the exoplanet's atmosphere. It's a question about whether the light is even trustworthy enough to talk about atmosphere at all. Because if the halo contaminates the planet's extracted flux, if it changes what you think the planet's brightness profile is, then any later spectroscopy is built on sand. Retrieval, the act of turning light into atmospheric constraints, assumes the light belongs to the planet in the way we think it does. If the light is biased, retrieval priors and model assumptions can quietly explain a lie. This is the second confounder. You have to name explicitly retrieval priors and model assumptions. Even before you do a full atmospheric retrieval, you are already assuming things. You assume symmetry, or you assume a smooth background. You assume how the point spread function behaves. You assume the speckle field is separable from the planet. Each assumption is a lever. Pull it hard enough and the data will comply. So the months-long analysis becomes a controlled argument with yourself. You ask, does the halo persist if we change the subtraction method? Does it persist if we change the region of the image used to build the star model? Does it survive different choices about how aggressively to remove speckles? Does it survive when we treat the planet as a point source versus allowing for an extended profile? And crucially, does it survive the most skeptical interpretation, where we assume it is an artifact until proven otherwise? Notice what's happening. This is not just about HR 8799b. It is the general problem of exoplanet atmosphere interpretation, detection versus meaning. We can detect faint light, but to interpret it, to talk about clouds, haze, scattering chemistry, we need to know what part of that light is planet and what part is contamination. And because this channel is ultimately about signs of life, we say the quiet thing out loud. This is what future biosignature and technosignature work will live or die on. Not on one beautiful spectrum, on the chain of custody for photons. A technosignature in an exoplanet atmosphere, an industrial gas, an anomalous absorption would be a claim that demands brutal proof against false positives. HR 8799b is not that claim. It is the rehearsal for the standard of proof. The title thread comes back like a refrain, now less poetic and more procedural. The halo around HR 8799b appeared in direct imaging, and then it refused to fit cleanly. That refusal is not failure. It is the method doing its job. A clean fit too early can be a warning sign in disguise. So the team tries to break the halo. They treat the data as guilty until proven innocent. They look for correlations with instrument behavior, anything that suggests calibration, drift thermal stability issues, detector effects that could imprint a ring or glow. They compare outcomes across reductions and ask what changes when you change the assumptions. They look for the signature of self-subtraction shapes that align with the algorithm rather than the sky. They make the question operational. What would I expect an artifact to do? And then they see if the halo does it. This is where uncertainty stops being a vague fog and becomes something you can test. If the halo is tied to the instrument, it should behave like the instrument. If it is tied to the exoplanet, it should behave like the exoplanet. That's the organizing logic of the analysis. Simple in principle, brutal in practice. And still, after all that, you may not get a single clean verdict. You may get a boundary, a conditional conclusion, a constrained possibility space. That's normal at the edge of detection. But the months-long analysis does something else that matters. It changes what seeing means. Seeing is no longer a picture. Seeing is a sequence of checks: observation, calibration, subtraction, stress testing, comparison, skepticism, repeatability. It is a discipline designed to prevent a false positive from becoming a headline inside your own mind. And now, with the method laid bare, the episode pivots. Because the next step is not to celebrate what we might have found. The next step is to assume we found nothing real at all, and to map deliberately and unsparingly the ways the telescope can become a trickster. We move from procedure to suspicion, from how we know to the change of perspective that follows when the data refuses to fit. A technician's hands hover over a control panel in dim light, a quiet room, a quiet hum. And on the screen, the same scene again, a star that's too bright, an exoplanet that's too faint, and the fragile suggestion of something around it, a halo, that could be physics or could be the instrument rehearsing a deception. This is the change of perspective, and it's not comfortable. We stop asking, what is the halo? And we ask, how would the telescope fake a halo so convincingly that we'd want to believe it's signal versus artifact, detection versus interpretation, the same photons, two stories. In direct imaging, the star never truly leaves the frame. You can mask it, subtract it, model it. But the leftover light is not neutral. It carries structure. And that structure can be stable enough to masquerade as a feature of an exoplanet atmosphere. That's what makes speckles so dangerous. They are not just noise. They are patterned contamination. So we name the confounder again without apology: instrument systematics, thermal stability, tiny wave front shifts, detector effects that don't announce themselves as errors, but as faint patterns that persist. These are known to create speckles, residual starlight features that can sit near the planet's location and imitate extended structure. A halo is exactly the kind of shape a human mind wants to interpret as real. Exactly the kind of shape an imperfect optical system can invent. Here's the first brutal question. Does the halo behave like a piece of the sky or like a piece of the machine? A real physical halo around HR 8799b should be anchored to the exoplanet's position. It should follow the planet. It shouldn't rotate with the instrument. It shouldn't bloom and shrink in ways that match a thermal cycle or a calibration shift. But artifacts can be clever. Speckles can be quasi-stable. They can sit there long enough to feel astrophysical. That's why the episode title matters. Direct Imaging Halo of HR 8799b, Speckle Artifacts, a months-long analysis. It tells you this was not a quick victory. The halo refused to fit, and that refusal forces us to treat the telescope like a suspect. Now we widen the suspect list, because one villain is rarely alone. Another confounder steps forward: time variability versus sampling. If you have only a limited baseline, only a few observing windows, random fluctuations can look consistent, and consistent artifacts can look like stable structure. The data can fool you simply because you didn't look long enough or you looked at the wrong times. In exoplanet work, this is a familiar trap a few transits can mislead. A sparse radial velocity curve can suggest patterns that collapse with more coverage. Indirect imaging, sparse sampling can let speckles impersonate permanence. So the test becomes a choreography of skepticism. If the halo is real, it must survive changes in time and method. If it is an artifact, it may reveal itself when conditions shift, when the instrument state shifts, when the calibration changes, when reduction choices change. But what if it survives anyway? That's where the trickster is most dangerous, when the artifact looks robust. Now we add the most unsettling confounder, the one that turns color into a trap: wavelength calibration and chromatic effects. Even if we never show a full spectrum here, the implication hangs in the air, because exoplanet atmospheres are read through wavelength. Small chromatic behaviors in the instrument. How optics and detectors respond differently at different wavelengths can create residual patterns that mimic a physical scattering signature. A halo that appears bluer or redder could tempt us toward atmospheric language haze clouds scattering slopes. But if that color trend tracks instrument behavior, it's a false positive wearing a lab coat. So we stage a thought experiment that doesn't add new facts but clarifies the logic. Imagine two halos that look identical in one processed image. One is astrophysical light, scattered by aerosols high in an exoplanet atmosphere, or by dust close to the planet. The other is mechanical, a speckle pattern shaped by the instrument, and the reduction perhaps with detector effects that give it a slight chromatic tint. On the screen, they can be twins. The only way to separate them is to ask each halo to do something the other cannot. That something is where the months-long analysis earns its right to speak. You don't just look once. You change the reduction pathway. You compare independent approaches. You stress test with injections. You ask whether the halo appears around other point sources or only where the planet is. You ask whether it behaves like an artifact when you alter the assumptions. This is the confounder test made concrete. If the halo is tied to instrument systematics, it should be sensitive to instrument behavior and reduction choices. If it is tied to HR 8799b, it should persist in ways that are hard to manufacture. And still, we hold the line between what we know and what we want. The method can generate persuasive artifacts. That is not a failure. It is the reality of high contrast imaging. Time variability and limited sampling can mislead, especially when we are hunting faint structure near bright stars. Cross-checks repeat observations, independent reductions. Different wavelengths are what increase confidence when something subtle refuses to fit the simplest explanation. If the halo were truly physical, a predictable wavelength dependence could eventually support an atmospheric scattering interpretation, but that possibility must remain conditional until the artifact pathways are exhausted. This is the limitation-heavy heart of the episode. The most honest outcome of a frontier method is often not a discovery but a narrowing, a constraint. A statement like the halo might be real, but here are the ways it can be faked. Here are the tests it must survive. Here is where uncertainty still lives, and there's a deeper reason we insist on this severity. The exoplanet atmosphere game is not just about describing clouds, it's about what we are someday going to claim. Biosignatures, if they arrive, will arrive as faint spectral features. Technosignatures, industrial gases, anomalous reflectance would arrive even fainter, even more vulnerable to contamination and model assumptions. If we ever point to something that suggests life or technology, the first reply from a responsible scientist will not be wonder. It will be, what could mislead us? This halo case is that reflex in action. So we come back to the title thread one more time now, with hard edges. The halo around HR8799b and direct imaging refuse to fit cleanly, and speckle artifacts are the most serious alternative explanation. That refusal is the story, not the embarrassment. It forces the science to prove itself. And now, after suspicion, we do the only thing left. We ask what survives suspicion. We take the smallest set of statements that remain true even after we treat the telescope as a trickster. We step toward the best current conclusion, not as a victory lap, but as a careful landing about what the halo allows us to say about HR8799b and about how much of the exoplanet's atmosphere we're truly entitled to interpret. The image steadies, not because the universe got simpler, but because the argument got stricter. On the screen, HR8799b sits where it should, a faint point of planetary light pulled out of a field that wants to erase it. And around it, the contested feature. This halo, the suggestion of extension, has now been through a gauntlet. Multiple reductions, multiple assumptions tested. The hard posture of it's an artifact until it survives skepticism. The months-long analysis that the title promises delivered not as drama, but as restraint. Now we arrive at the question we've been withholding, because it's the only honest question at this point. After all the falsification attempts, what can we responsibly say? Not what we wish, not what a single striking frame implies. What survives? First, we say what is solid. In direct imaging, speckle artifacts are a primary confounder. They can create faint structured residuals that mimic halos. That remains true no matter what the halo looks like. So any conclusion about HR8799b must be framed against that threat, not around it. The title is not decoration, it's the credibility frame. Direct imaging halo of HR8799b. Speckle artifacts a months-long analysis. The halo is only meaningful in the shadow of speckles. And the months-long analysis is what prevents a false positive from becoming a comfortable story. Second, we accept the shape of a cautious inference. If residual structure persists under robust cross-checks, if it does not collapse when you vary the reduction pathway, if it does not appear as a generic artifact around anything bright, if it behaves as though it is attached to the exoplanet more than to the instrument, then a physical component becomes plausible, not confirmed, plausible. And in this context, physical component is deliberately broad. It could be scattering in a high-altitude haze, or cloud layer in the exoplanet atmosphere, or it could be circumplanetary dust. The outline doesn't allow us to pick one winner. It forces us to keep the inference conditional because the data at the edge of contrast rarely gives you a single clean answer. Here's the evidence moment that matters most for the audience. The best conclusion is not halo discovered. It's here is what the data will not let us ignore, and here is what it still might be fooling us about. That is what a frontier measurement sounds like when it is telling the truth. Now we pivot to why this matters for atmospheres, because this series lives in the chain from data to meaning. HR8799b's halo question is not only about a shape in an image, it's about what that shape does to the planet's extracted light. If the halo represents real extended scattering, then the planet's brightness profile, how its light is distributed, changes. That affects how you interpret the planet's colors across wavelength. And that is the front door to atmosphere interpretation, even before you ever say the word spectroscopy out loud. Retrieval depends on the integrity of that light. But we also acknowledge the second trap: even a real halo doesn't automatically simplify the atmosphere. Clouds and hazes create degeneracy. They can mute spectral features. They can flatten what should have been distinctive. They can produce similar observational signatures through different physical pathways. This is the confounder that lives on the far side of success. Even if the halo is real, what it means is not unique. So we name the limitation explicitly as the outline demands clouds/hazes degeneracy. The same apparent scattering signature can be produced by different aerosol properties, different particle sizes, different vertical distributions. And in the absence of broader wavelength leverage or repeatable spectral constraints, you can end up with multiple atmospheric stories that fit the same light. This is where the tone becomes quietly ominous. The universe doesn't just test whether you can detect a signal, it tests whether you can interpret it without lying to yourself. Detection versus interpretation. Model fit versus calibration drift. Planet atmosphere versus contamination. We fought one battle signal versus artifact, and even if we win it, another battle begins immediately signal versus multiple meanings. So the best current conclusion takes a specific shape. It is conservative. It avoids overreach. It reads like a contract with reality. The data require careful accounting for speckle artifacts before interpreting faint extended structure as planetary. If the halo survives robust cross-checks, a physical scattering component becomes plausible. Any atmosphere claim should be phrased as constraints limits on scattering or cloud opacity rather than a definitive declaration of a new structure discovered. If future observations show consistent wavelength-dependent behavior that resists chromatic speckle explanations, then the halo could inform aerosol models and exoplanet atmospheres, which is part of the methodological path toward more life-relevant targets. Notice what we are not doing. We are not turning HR8799b into a near-term biosignature stage. This is not the habitable zone. This is not a planet we are about to call Earth-like. The outline doesn't permit that drift, and the science doesn't deserve it. HR8799b is a training ground for inference, the place where we learn to treat faint light with discipline. And that discipline is precisely what the search for life will need. Biosignatures. If they arrive, will arrive as fragile features that must survive a similar gauntlet of confounders: contamination instrument, systematics model assumptions, false positives, technosignatures, if they ever surface through exoplanet observational channels, would demand an even harsher standard. The point is not that this halo is a sign of life. The point is that this halo teaches us how not to hallucinate life from the wrong photons. So we settle on the quiet truth. The halo either is an astrophysical clue we have not yet fully pinned down, or it is a demonstration of how convincing artifacts can be at the edge of detection. Either way, it is valuable because it forces the method to be explicit about uncertainty. And we end this part the way the outline insists, not with a finale, but with a named measurement we still need. Because the story doesn't end with belief. It ends with a question that can be tested. The halo around HR8799b in direct imaging refused to fit cleanly, and that refusal points forward to the measurement that will make it confess one way or the other. We're going to name that measurable unknown next, and what kind of future data could finally separate atmospheric scattering from chromatic speckle behavior. The room is darker now. The image on the screen looks almost like a finished thing-star subdued planet, present the faint edge of that halo hovering, where it has hovered all along. But the final move is not to add certainty. It's to remove the last illusion that certainty is owed to us. We let the processed frame dissolve backward. First, the halo outline fades. Then the planet itself becomes less obvious. And finally, the star's glare returns, filling the scene with the speckle field, structured, restless, persuasive. The raw truth of what we're doing. Extracting an exoplanet from a storm of contamination. Asking faint light to carry meaning without being bent into a story we prefer. This is where reflection belongs. Not as philosophy floating away from the data, but as a disciplined reminder of what exoplanet atmosphere science actually is, inference under constraint. Direct imaging is a frontier method for exoplanet atmospheres, but at the faintest levels, instrument systematics can dominate. That remains true whether the halo is real or not. The method itself teaches caution, and the title thread returns one last time, not as marketing, but as a verdict on process direct imaging halo of HR 8799B, Speckle artifacts, a months-long analysis. The credibility is in the months. The seriousness is in the willingness to say, the halo refused to fit cleanly, and we will not force it into a clean narrative. So what does that refusal teach us? It teaches that a measurement is not a claim until it survives cross-examination. It teaches that the most dangerous false positives are not the obvious glitches. They are the beautiful, stable artifacts that look like physical structure. And it teaches that the pathway from a detected exoplanet to an interpreted atmosphere is a chain, not a leap observation calibration model conclusion, and every link can be weakened by contamination. Here is the second evidence moment of this final section, and it is deliberately measurable because our ending is not mystical. It is specific. The named unknown is not, is it real? The named unknown is, does the halo behave with wavelength? Like an astrophysical scattering signal or like chromatic speckle behavior. We say it plainly because it matters. The measurable unknown is the wavelength-dependent halo slope and radial brightness profile. How the halo's brightness changes with the wavelength. How it falls off with distance from the planet. Those two behaviors, color and shape, are the interrogation. If the halo is physical scattering tied to the exoplanet atmosphere, it should show a pattern across the wavelength that is difficult for instrument systematics to counterfeit consistently. If it is speckle contamination, it may track the instrument's chromatic behavior, revealing itself when you change observing setups or reduction assumptions. That is not a poetic unknown. It is a data request. And this is where we carefully connect it back to the broader micro-niche without drifting into hype. The search for signs of life biosignatures in an exoplanet atmosphere, technosignatures, detectable through atmospheric industrial gases or odd reflectance, will live in the same logic. Any future claim along those lines will hinge on subtle, wavelength-dependent features extracted from light that is contaminated, calibrated, and modeled. The halo case teaches the posture we will need then, when something appears that seems to promise meaning. The first responsibility is to ask how it could be fooled. We also hold the boundary HR 8799B is not being framed as a life candidate. The habitable zone is not the focus. Earth is not the main analogy. At most, we can allow ourselves a brief calibration, just as looking through haze on Earth can blur what you think you see haze, or clouds in an exoplanet atmosphere can blur spectra. while speckles can blur the image itself. And then we return immediately to HR 8799b, because this is where the lesson is earned. So what would resolve it? Not a louder conclusion, better constraints. Repeat direct imaging observations across broader wavelengths with stability that makes instrument systematics less able to masquerade. Independent reductions that agree without being tuned to agree. A pairing with direct imaging spectroscopy, not to proclaim new chemistry, but to test whether the halo's color behaves like physics or like a machine's chromatic fingerprint. This is all still within the outline's promise. Future data must force the halo to reveal whether it is atmospheric scattering or chromatic speckle behavior. And then we let the final image do its work. Option 1. The honest reversal, the halo dissolves all the way back into the speckle field, and you feel how close to the edge this work is. Option 2. The disciplined stillness, a stabilized frame of HR 8799b, with the faint halo hinted, then the hint removed, leaving only what we can defend. No triumph, no despair. Just the quiet truth that the cosmos is not obliged to be legible, and that the only way we earn meaning from an exoplanet atmosphere is by treating every tempting feature as guilty until it survives the full list of confounders. The halo around HR 8799b refused to fit cleanly, and that refusal leaves us with a single measurable demand map, the halo's wavelength-dependent slope and its radial brightness profile, well enough that scattering and speckles can no longer share the same mask. Only then does interpretation begin, and only then do the bigger questions about biosignature claims, about technosignature possibilities, about signs of life, get permission to step into the light.